All right, this is for you, Naomi. I wanna go over 6 one more time because I finally got a better way to explain to you why some of those solutions are erroneous. So let's take one more look at this problem. Had to do a little bit of research about a method that's easier to understand. Okay, so let's do the same steps we did before. Isolate this part, so we're going to subtract 3x. Then we're going to get absolute value of x minus 3 equals 5 minus 3x. Okay, and now we're going to split this again, just the same. We're going to say this can be either positive that or negative. So we're going to write x minus 3 equals 5 minus 3x, or x minus 3 equals negative 5 plus 3x, okay? And now we'll solve each of these for x. Add 3x, so 4x minus 3 equals 5. Add 3 to get 4x equals 8. And x equals 2. Okay? And then same thing over here. We're going to subtract x. Negative 3 equals negative 5 plus 2x. And then add the 5 to get 2 equals 2x, or 1 equals x. Now, as we learned before, this 2 is an erroneous solution. Okay, it doesn't work. We tested it, it didn't work. And the 1 did work. Okay, and now the clearest way I can show you why this is an erroneous solution is because look at this step here. Okay, we have x minus 3 equals 5 minus 3x, right? So if we plug in 2 back into this, it's going to work. I mean, that's what we just did, right? This is going to become 2 minus 3 is negative 1, and 5 minus 6 is negative 1, right? But here's the problem. This side has to be negative for those to be equivalent, right? This is negative 1, and this is also negative 1. But can an absolute value of anything ever equal negative 1? No. The value of this has to be positive for these to be equivalent, because whatever value this has is going to end up becoming positive. So if when you plug your solution in here, this is negative, and in this case it is, this is going to be negative 1, you can already tell that that solution is going to be false. And the way you could have known from algebraic steps that was going to happen is you could have used an inequality sign, because that's sort of technically what we're doing here. It's like you're solving for this as well as this. Okay, so technically both of these have to be true. Like they have to be equal, but this also has to be like, this also has to be greater than or equal to 0, right? Because the smallest this could be is 0. It couldn't be less than 0. So really, if you wanted to be like technical about it, you're solving for both of these, and whatever solutions you get for both of these are the actual solutions. And so this would generate the solution of 2, but when you plug that 2 into this, this part would be false, because this is going to be less than 0. So that's the way you would rule the solution out, is by noting that whatever you have here has to be greater than or equal to 0. Okay? I hope that makes a little more sense, and I hope I'm not still just wasting your time mired in confusion. Take it easy.